Today we're going to be talking about a project that I've been working on helping with involved with law search. I'm Doug, by the way. That's my Twitter handle. I'll reintroduce myself in a second as I get to my slides. So what we're going to be talking about is State Decoded, which is a state law search project. I'm going to give some motivation why this is important, why this is a socially important. Search and discovery around laws is very important socially for our society. We're going to dive a little bit into the data, what the structure of the data is, what it looks like, why, sort of give you some foundation on the search problem. Go through some easy problems where Solr really helped, and some medium problems in there where we could figure out how to get Solr to sort of solve our problem for us. And then we're going to get into the meat of what the real, actual hard problem in legal search is. So to start out, I'm Doug again. That's me. So yeah, these are the laws that we're going to, these are a sample of Virginia's laws. We're going to refer back to this from time to time just to get an idea of sort of the search problems that occur in this corpus of text. Now, the real root of why this is important gets back to equal access to laws. And related to equal access, as a foundation of this, we need to sort of define something else that you guys might not be aware of, this concept of equal protection under the law. So the law says, even the idea is that basically the laws apply equally to all of us. There's no special cases. We all live under a society of laws, and I can't just decide that I'm not going to follow that law tomorrow. And it's pretty foundational for society. There's a lot of countries where that's not the case, and we're fortunate to live in a place where the laws are pretty evenly enforced, and relatively speaking, we enjoy rule of law. But the real issue is how do people access the law? And is the law accessible to everybody? There's a couple different ways that places of the law might be kept. Are all those places accessible to people? We have sort of maybe in a database or a legal search online, like a LexisNexis kind of product, sort of targeted more for lawyers. We have books, we have tablets back in the day. We have all kinds of individual ways to store law. And when we look at those mediums, the real crux of the question is, who is the audience for these mediums? Is it everyday people? Or is it these guys? Lawyers, bureaucrats, and politicians who write laws and then are also the people who are going to be applying the laws most frequently. It's a lot different than this group of people who don't have expertise in the law, but still we all live in this society where the laws affect us all equally. So socially, it's very important for when these guys have a problem to be able to refer to something so that they can find the laws that protect them. So which side is better equipped to find the law that protects them? That's really the crux of why this is an important problem to solve. We feel that, and this is where State Decoded comes in. So Waldo Jacques, he's the founder of the project. He started this for the state of Virginia, which is the set of laws I'm going to be referring to. And several people have started sort of websites, sister websites for their own state's laws, for the states that nicely provide dumps of laws that you can download, standing up Solr and the State Decoded application around that. I work at OpenSource Connections. And we live in Charlottesville with Waldo, so we're helping him with the search process. What the application looks like is we've got open state laws. We've got some dump that the state was nice enough to provide us. It's not really the same as providing a search engine online for laws, which, how do you crawl a search engine that the state provides? And we combine it with Apache Solr and the application written in a LAMP stack. And we get law search and discovery for everybody. So the audience here, of course, is very different than your traditional legal search, which is more targeted towards very technical users. What we're trying to do is target sort of everyday people, the kinds of people who are going to be very infrequently be affected by laws, but when they need to have their day in court, they should have a resource that they can refer to that will help them, and they doesn't necessarily require an expensive lawyer to dig through. So what does the data look like when we're talking about laws? So pretty simply, and this is just a general sort of overview of the pipeline, Waldo has defined a standard XML format that other people convert whatever format their state's laws are into the standard format. And it's pretty straightforward. There's the text of the law, and there's very simple fields. So we translate that into that XML format, and we simply have an ingestion script that turns it into Solr, sends it to Solr in the MySQL database behind the application. And voila, you have a very pretty app that helps people find laws that impact them. Your mission, if you choose to accept it, and this is the part where you have funny cat pictures, because every presentation needs that. If you're looking for a way to contribute and contribute meaningfully as a developer, there's a couple of things you could do here. First, this project needs people to take state laws and sort of convert them to the standard XML representation. Secondarily, if you're interested for your state, if there's not already a State Decoded, we'd love to talk to Waldo or myself, and would love to hear more if you're interested in hosting a State Decoded website for your state. And finally, you can tell me all the things that are wrong with my presentation and my ideas, and just contribute to the project, help us out. So getting back to the search data, we have a very manageable data set for Solr. We have just 31,000 laws. Each law is roughly a couple paragraphs. And to help people out, we've got a law dictionary of just common legal terms. So what is guardium ad litem mean? That kind of thing when you encounter it in the law. And that's the corpus that we're working with pretty straightforward fields. These four being from the laws itself, the text, the section, which is the number, the structure, which is just names of sections to give you some context, a catch line, aka title. I'm not sure where the term catch line comes from, but it's basically the title of the law. And then for dictionaries, we have got legal terms and legal definitions. So this is just to show you, here's this, when I say section, this is the section, this is the catch line, this title up here, and this is example text of some laws. So given that data, we've got it ingested into Solr, and what Waldo's app, before we started our engagement with Waldo, he had a pretty rudimentary Solr that didn't have any sort of tuning for his data. He was just everything was basically treated as text, and it's kind of worked, but there's a lot of searches that we found were not really returning relevant results. Combing through his search logs, trying searches out ourselves about if I was in a sticky situation, maybe with my car tax issues, how relevant are the results to my problem? And you can see there's a couple classes of different kinds of broken searches that we sort of discovered. And I'll go through sort of each of these and discuss what we did with them. Some sort of stupid problems for phrase queries. His PHP code is just not passing the quotes to Solr. That's pretty easy to fix. And so, of course, there's phrase queries don't work. Real estate, the query real estate is interesting because what the results are coming back, we're getting dictionary terms, right, in his current application, get dictionary terms collated with the actual laws. And the scoring of those things, I don't know if everyone realizes this, but scoring in Solr is a relative scoring. So sometimes you get, for a query like real estate, you'll get nothing but dictionary terms and no laws related to real estate for a while. And sometimes you get vice versa. It's like if I click for a while, I might find the definition that affects me. So that's just an issue where maybe we need to sort of think about on the client side how to sort of separate those scoring models, separate the corpus's scoring a little bit better. Then we get into the meaty problems where we're actually digging into Solr configuration. And all of this stuff, these searches, we addressed entirely with vanilla Solr. One of the most popular searches is just, of course, someone typing the section name into the search and expecting that law to come back. Or maybe they'll just type 1-206 and expect all of the laws that begin with that to come back. And people tend to use a couple different delimiters for this, dashes, dots, that kind of thing. And you can see that here. You know, here's some section numbers. That's the kind of stuff people type in, expect to get that law back. Turns out this is pretty kind of interesting. Whoops. What we ended up using, first thing we ended up doing is taking all these dashes and dots and just normalizing them to a tilde with a car filter. So we do a pattern replace car filter. Here we've got dot dash change to tilde. So we've got a normal sort of path that we can work with. Side issue, some people there's a subsection which is actually within our document that we're not actually treating separately in parentheses. So we basically kill any parentheses, trailing parentheses, or square brackets that come after that. And then the sort of interesting part about this is we use the path hierarchy tokenizer. And what that does is for stuff that's kind of pathy and you want to find stuff in the tree that's related, it sort of leverages TF-IDF, the normal scoring model and the term frequency, inverse document frequency scoring model, by expanding these kind of sections. We start with 1-206.5. Of course, we switch to tildes, expanding it into these three terms. So if someone was to search for at query time and index time, so if someone wants to search for 1-206, that will get expanded at query time to 1 and 1-206, and the results will come back will be very related to that location on the tree, with, of course, the exact matching all three of these terms coming back exactly. So that's kind of an interesting thing that we did. Second class of searches is phrases. Phrases are very important in the law. You can see just looking at this corpus, Commonwealth Transportation Board, Commissioner of Highways. There's a lot of phrases, key phrases that people use in legal search and legal terminology. So this was not a hard thing to solve. Of course, Solr provides a PF option. So we just made sure that our text fields were set up as phrase fields. And a final sort of interesting problem that sort of gets at the harder part of the easy scale. It turned out that No Child Left Behind is actually in the corpus. We searched for it. Interestingly, it still returns 0 results. And we started seeing this after we changed QF. And this is kind of interesting. If we turn on debug query and we just added, say, the catch line to QF, one of these things, it turns out that text is stop-worded. So what the dismax query parser does, it takes No Child Left Behind, creates a Boolean query across each of those fields, no in each one, child, et cetera, except for text, no is a stop word, and that gets chucked out. So suddenly, with a min match equals 100, which I left in for stupid reasons, this becomes a mandatory clause. So by adding something to QF, by searching more fields, I actually got no results or fewer results because no doesn't actually occur in the title of any laws, apparently, any state laws. And so we just made sure that we had a more reasonable min match. This is kind of the funky syntax that Solr expects, where it's 25% if it's between 2 and 5, and 50% must match past 50. Are you guys familiar with min should max? Yeah. OK. Yeah, so min should max is basically just saying of this Boolean query, this percentage should actually has to match, or we're throwing out the result. So in this case, I'm saying if there's 2 to 5 terms, 25% and 50% for past that, which is kind of, if you think about it, actually, I think that should be reversed, because as your queries get longer, you tend to have more stop words, because people type in questions like, what is the capital of Spain? You know, capital Spain is probably all you need. If someone has a short query, that tends to be much more sort of potent of a query. It's capital Spain, capital of Spain. There's the stop word ratio is much, much less. So that sums up the easy problems. Now, law search actually has a very hard problem that we're working on. The basic problem is what these guys search for. Here's our everyday people, the guy from Dinosaurs and the guys from Monty Python. Car tax, teacher pay, actually turn out to be much less jargony than what the people who wrote the laws, the lawyers, politicians, and bureaucrats search for. So what these guys search for, motor vehicle procurement, educational compensation, is what's much more likely to be in the corpus of text. Why? Because these guys write the laws, and laws tend to be technical and jargony. So how do you sort of convert the layman's sort of description of something, car tax, into the technical, jargony version, or get some kind of an understanding of some association there to give people the results that are relevant to them? And for the most of the searches that we tried that were broken, this was a very sort of pressing problem. This is the biggest problem that we found. We've been trying a couple different tracks along solving this problem. One track that we've been going down is using a technique called latent semantic indexing. We've played around with singular value decomposition and something else called random projection. And those are just statistical ways of sort of figuring out statistical relationships between words. So you could do basically synonym detection if you had a large corpus that had car and motor vehicle co-located pretty heavily. The problem with this is the law is already very heavily sort of normalized around legal jargony language. So there's not a lot of associations to detect statistically. You're not going to find car in the same document as motor vehicle, because laws always say motor vehicle. So you can't do that against that against the legal corpus. Another idea that I was talking to Joel about yesterday actually is trying to use Solr join to sort of detect legal terms. Solr has a new feature called in 4.0 called Solr join, and it's basically an inner join. But what I was hoping to be able to do was to take this term, search a law dictionary for maybe the top 5 most relevant results against the law dictionary. So motor vehicle might come back, because that's in the legal dictionary. And then take those top 5 terms, kind of based on the relevancy of car in their definition, and then turn around and search the laws against that. Problem is that it's a pretty blunt instrument. Solr takes every document that matches car, all whatever thousands of them, treats them all as equal citizens for joining into laws, and it's not fuzzy at all. It's really built for IDs, taking all these IDs and matching them exactly with all these IDs. So that didn't quite work. We thought about using Mechanical Turk to kind of take jargony terms and generate synonyms.txt around legal terminology. Of course, the problem with this is the average Mechanical Turk user isn't going to necessarily know what guardium ad litem is. We need Mechanical Turk with lawyers, like guaranteed lawyers. And I doubt I can afford that. Wordnet, this is kind of the more traditional synonyms. Probably should have started with this. Just simply using Wordnet, which is a database of synonyms, hyponyms, et cetera. And it's similar problem. I mean, Wordnet isn't necessarily going to have lots and lots of legal terms. It's more general purpose language. Circling back to sort of where we're going next with this, I'll just back up a little bit. So one thought for we're sort of still tweaking these ideas. One thought, and I'm really curious to hear what you guys think about this problem too. One thought for latent semantic indexing is taking the legal dictionary, combining it with a normal English dictionary, and maybe find statistical relationships between those corpuses put together. Like motor vehicle co-occurs statistically frequently with car in the regular dictionary. So maybe if we can combine those, do some sort of statistics around that, find co-occurrences, to do a little bit better synonym detection by mixing legal jargony stuff with the sort of regular plain English dictionary. So we're playing around with that. We're also playing around with maybe writing a request handler that can handle sort of doing fuzzy joins as opposed to doing the current join, which is very straight sort of ID matching. So kind of expose more functionality that we would need. Finally, or in addition, if anyone knows of Mechanical Turk that will give you lawyers, I'd love to hear about that. Or we might be able to get some sort of legal aid volunteers to help with this. Wordnet, yeah, I'm not sure we're going to keep looking at this, although there's a really good chance that just basic synonyms are just going to get us maybe 40, 50% of the way there. So we might just end up using a combination of a plain synonyms.txt file with some of these other more advanced techniques. So yeah, so talked about why legal search for everybody is important, not just legal search for lawyers. Talked about the data, how you can contribute to this project. The easy problems that we went through is kind of interesting, and sort of the harder, real meaty problem of this. So thanks everyone for coming. I appreciate the attendance, and feel free to come and give me your ideas or questions. So thanks.